Okay, so we are starting our last training session of this short summarized series of Tableau training. We talked about the supported data sources from Tableau Public, and we checked how to load and relate different tables data and how to configure or manipulate the data, change data types or split and so on. Also, we went through the different types of data visualization or different graphs. We tried a simple calculation here and some of the more advanced or complex calculations. Also, we have here tried the ranking functionality, and we put all together in a dashboard. This is where we finished or were done last week. So I will start this week with a summary of what we will be covering today. We will show the forecasting functionality of Tableau and also the clustering and trend lines, which is correlation, and also the reference lines. And I will show you the explain data functionality of Tableau. It's a nice and cool feature. And finally, we'll show you how to use parameters in our visualization to have a more dynamic dashboards. Okay, so let's get started with the forecasting. So what is forecasting? Is simply using statistical model to generate predictions for future data using historical information. And Tableau comes with an out-of-the-box functionality of forecasting using forecasting algorithm called exponential smoothing. This algorithm, Tableau implemented this algorithm, and just to use it, you just go to analytics and use the forecast. But before, you should provide your view with a date dimension and a measure. So we have a lot of date dimensions and measures. We can go and try with any couple of them. So let's try with the ship date and the shipping cost. Just here. Switch to the line here. So now we have the our line indicating each quarter and the shipping cost, representing the shipping cost of each quarter. And to add the forecasting here from analytics, just drag and drop forecast. And now, as you can see here, it's generated forecast for 2016, quarter 1, 2, and 3, and 4. As I said, it's using exponential smoothing algorithm, and it requires a date dimension and a measure and at least 5 data points. We have here more than 5 data points. So it will use the historical information and feed it to the algorithm, then show us the forecasted information. This can be, but we can slightly configure how the forecast run. Right click here, forecast, then see the forecasting option. From this window, you can set or configure the forecast length for exactly or until select 1 year. Here's the default. You can make it 2 or 3 years, so it will update the view, the background. Also, the source data, you can configure it to ignore lost 1 or 2 quarters, or based on quarters or months or whatever. This functionality is handy and very nice one in case you have your last quarter is the current quarter and it was not it's not yet over, so you can configure your forecast to ignore the last one or two items, whatever. Also, this one usually in data science sometimes it will be better for algorithm to work is to have values instead of nulls or missing values. Also here we have the model. Tableau suggests or advise to keep it to the automatic, so their engine will make the best model. But here you can use the one with seasonality or custom. The custom one will we can configure whether it's additive or multiplicative and the season as well, how to work with the season. But for most of the cases, the automatic one will do the job. Here is the prediction interval, which is 95%. So it gives the range of data or the range of your forecast given that this interval. So 95% of time, the values or forecasted values will be within these ranges. You can go and try a lower range. So this will narrow down the range or higher one. So you will have a longer interval. Also, we can here like get the exact forecasted values. So here for the summary, you can see the change from initial seasonal effect, water one too high or low, have the seasonal effect. Actually, personally, I'm not experienced with this algorithm itself, but you can get the information here regarding different measures that you can evaluate the prediction using these matrices. Based on these values, if you have a background about this algorithm, you can measure or evaluate the forecast and how whether it's accurate or not, and determine the quality of your forecast. Also, there are some smoothing coefficients, alpha, beta, and gamma. And I think if anyone interested in this forecasting algorithm can read more about it. Okay, so this is regarding the forecast. Oh yeah, that's done here. Also, I can show some details about the clustering. So the next functionality to present today is the clustering. So I opened here this sheet that we created last week, and I will simply duplicate it. So you can work with the new sheet here. So clustering, if you don't know what clustering is clustering is simply a statistical analysis technique where you can identify which items are more related to each other more than other items based on some characteristics. In this case, we can work with the relation between sales and profit. I will just make the graph easier for us to interpret when we make the clusters. So here, this might not be the best plot for clustering, but let's see how it will do it. So as I said, clustering just try or a technique or algorithm to trying to group different points together or in different groups based on their here in visually you can expect that you might have this one as a cluster and these dots or points as a cluster. It might have this one as well. So here as well from analytics, like we did for the forecast, we can drag and see the cluster. Yeah, and from this menu, it's asking about the variables that will be used to generate the clusters, and even the number of clusters that you want the algorithm to output. In this case, it's automatic and it generated only 2 clusters. Group this one as a cluster and the other orange as another cluster, and here we can configure the number. So if we make it 3, here we have like 3 clusters and so on. The algorithm used is the k-means, which is the most famous clustering method out there. Also, can see some think from analytics or analysis. Sorry, no, trend lines date. Analysis. I'm looking for a way, yeah, highlights cluster. So let's generate it again.
How are you creating that cluster? Are you just dragging it onto
Yeah, just drag and drop. It's already you have the algorithm implemented for you. These type of algorithms, just like imagine it as a function that takes the whole data set, and in this case it takes the number of clusters that you need to cluster your data with, and it output or assign each dot of these dots to a cluster. So simply, yeah, just drag and drop to your view, and the automatic thing, it automatically or recommends clustering or grouping the data into 2 clusters, but you can, as I said, you can configure it to any number of clusters. Set to 3, 4, and so on. This when I set it to 4, you can see this dot it was taken away in a different cluster, just like so. Also, yeah, what I wanted to show you is, yeah, from this, yeah, the describe cluster. That was the thing that I wanted to show you. So this displays a summary of each cluster. So in our case, we have 2 clusters showing the number of items in each cluster, and the sum of profits and sales is based on the 2 measurements that you used, that I used to create the clusters. Here we have the number, some information, also some information about the model, the F statistic and P value, sum of squares. All these are indicators and measurements to evaluate the cluster. So you can work with a different number of clusters and check these values till you reach the best model. But if you leave it automatic, Tableau will display the best one by default. Okay, moving to the next feature, which is the trend line or correlation. That's a very interesting one. So this one is, I think some of you who work with or studied algebra and know about the correlation. So when you have some points plotted in XY sheet like so, and you want to derive a model or a function that you can get the Y value using the X value from these points. Our current data set, it doesn't have good values or good data set for clustering, so we will be using another one. I think I need to stop the share and share the page again. Yeah, this one. Let me, yeah. So as you can see here, we have these x and y values. This relation or this data source is just generators, wind generators, power generator from wind. So you have your input as the wind speed and the output is the power output for different windmill. And when you plot these values like so, you can simply know or derive that indicate that the wind speed, the more wind speed we have, the more power generated. So it's increasing, and from the shape of these dots, it's almost a linear relation. So what we want to do is to derive a model to derive the line that that best represent these values. So you can using this line, you can determine or derive the power output given the wind speed. So to add this here again from the analytics, you can create the trend line. So drag here, you can add the linear or logarithmic or exponential or polynomial or power. In our case, it looks like a normal linear relation, so I will try the linear one. Now it displays the trend line, as you can see here. And if you put the mouse over this line, you will see the model. So you have 2.2 multiplied by the wind speed minus 6.4. This is our model. And if you studied this correlation, you know that you can evaluate this model using the p-value and r-squared. So the smaller p-value is, the better your model, and also the r-squared. I think p-value, as long as it's less than 0.01, it's good, and also the r-squared should be around 0.95. Yeah, I think r-squared is just evaluating how far is each dot from the line, and calculated relative to the current value. Also can edit your model from here. You can select the model type again. You can shoot tooltip or confident bands, like so. So this is the confident bands. It's 95%. Also, if you have different groups, so you can create a trend line for each group. In our case, in the global superstore, we had 3 product categories. So we can, if we have a good data set for correlation, we could use or create a different line for each color or each category if we divide it using or distinguish it using the color. Also show the recalculated line for highlighted and selected data points. If you select a subset of data points, it will generate a different line, okay, based on the points that you selected. This one you can see here, these are considered noise, and also this one. So if I tried and to derive something that just work for these values, so I might end up with a different line with slightly different values and a different model. Yeah, and that's it. What else here? Let me check my notes. Yeah, just to apply this trend line, you should have two measures in your view. So if you put like a measure and a dimension, it will not work. Like the dimension, so it will not work. Yeah, I mentioned how to evaluate the model using the p-value and the r-squared. There are other more detailed ways to evaluate the model, but it's all out of our training scope. But anyway, this should give a good indication, but to judge two models with similar p-value and r-squared, you should check other measures. I'm not sure. Yeah, you have the standard error, the t-value, p-value. Yeah, but there should be more details about this model. But anyways, this is not bad. It's ready for you. Just you can drag and drop it. Also, regarding these for forecasting and clustering and the trend lines, if anyone worked with data science libraries in R, Tableau has integration with R, so you can, if you have a ready function in R, you can import it to Tableau. Here you can create a calculation, and yeah, this use any one of these script call, script integer, script real, or script string. This type represent the returned type from your R script, and simply it takes your function and the input and returns the type based on the selected one. But again, I did not try it. And I think that if you are already working with R or Python, these tools, they have their plotting or data visualization libraries. So you would prefer using the libraries of these tools, not to include in Tableau, but anyway, it's there in case you need to use it. Let's go back to the global superstore. So the next functionality is the reference line. So let's see if we have here any sales. Yeah, we can use this sheet for it. So I open the sheet and duplicate it to use it directly. So in this sheet, we have the product category and the product name, and here we are displaying the sales. So this menu as well, we have constant line, average line. You can add the average line per table. So it will it represents the average across all the table. You can make it for each band or a band, sorry. Also, we have the reference line. Reference line. You can put a reference line, so it will pop up this menu window. If you want to use a reference line or reference band or distribution or box plot. So the reference line, you need it just to maybe a static value representing a specific value on this diagram, or can adjust it to represent the average, the sum or constant or maximum or minimum. You can make it line or with confidence interval. Also here, yeah, I just want to, yeah, as you can see here, if I drill down to technology, this triggers a different average line other than the one when I roll up my calculation. Also, what I want to adjust here is sorry. Edit. Yeah, the scope of the your reference line. So here I got it the entire table. So this average representing the average across all values of the product names across all the lines or rows of data. But I can have my average per pane. So if I set it like so, you can see here that I have two different average values, or three, one for each pane. So for technology, I have average 2030, and for furniture, it's 1957. And for the last one, we have a different average as well. And if I roll up data, this should give the same value as here. I have only one pane, so it should not give any or make any difference if I select per pane or entire table. It's the same. Yeah. Also, we can set it to like a constant number. So set the value you want. So if you want to put a line representing 2000s, so it will be like so. Average. Well, okay. So we said we have seen this scope, but also we have the reference band. Can try it as well. So the reference band, you give it the minimum and the maximum. It's like the reference line, but it has like a minimum and the maximum. So you can set like the minimum constant to 1,500 and maximum to 3,500. So it will show a band here in the background. You can see it. So this one is a good feature to get or to display more details in your view. So from analysis here, trend lines. Okay, anyways, what is next in our agenda today is explain data functionality. Yeah, that one is so interesting and new. This is the newest feature, added feature to Tableau. So explain data is a very intelligent feature where you can like select a specific data element from your view and ask Tableau to describe or explain why this element is given like, a very different value or far from average value compared to other values. So let's go and try it with any one of these. Yeah, I think this one is way much higher than other products. So let's ask Tableau why we have this. So just simply you have to select it like so. From this menu, click this icon, explain data. So it will go and make its analysis and generate a report for us. We can see the contents here, or contents of this report. So here, technology, Canon image advanced copier, displayed measure, some of displayed measure, which is sales. The sum is 61,000, is higher than expected. Then it will give us some possible explanations. Here, the average of displayed measure. So the selected mark technology, Canon, has a higher than expected average of displayed measure. Here we will have a more detailed explanation. So the selected mark has average displayed measure of 12,000, higher than expected average of displayed measure mark is increasing the sum of displayed measures. So the average is higher than other. So the average is high. That's why, or that's one reason why the sum is high. Extreme value. The second point here is extreme value. So this item made of 5 records. One record with value of 17,500 is increasing the sum of the displayed measure. If this extreme value is executed, the sum of displayed measure changes from 61 to 44. So telling us that there is one record with very high sale value, which is causing this to go higher than usual, and also providing us with this record changes aggregated value from 44 to 61. So this would give, and this is as well how the graph or our bar chart would look like if we remove this value. This one would provide us a very detailed analysis. It depends on the data set itself, but I have seen a lot of demos where this feature is doing amazing job in describing and explaining different trends in data, and whether you have like a very high value or very low value. It provided the user with a good explanation, and given even more complex situations than our situation. And it's available as well from Tableau online. So you can open any dashboard and use it from Tableau online and try this feature as well. Yeah, and now moving to the last feature today, the last addition. Here I have implemented it already. So what I will do that I will revert the work and show you how to do it again. Okay. United States. Yeah. Okay. So here I was just trying to revert back the work that I did to do it again with you. So we left this sheet last week, like so, displaying the category, product name, and sum of sales, and we tried what I did that during the weekend I go and try to use the parameters from Tableau to adjust or give more dynamic functionality to my dashboard. So imagine a situation where when you need to change the measure displayed here in this sheet. So in this sheet currently, I put this measure sales and it's a static like so. But if you got like a requirement where your customer requested to have like the option to display sales or profits here on this graph and be able to switch between them. So how to apply this is using the parameters. What is the parameters? Actually, the parameters or columns that you add to your data set. It doesn't come from the data set itself, and it does not depend on a measure or derived from a measure. So it's a value that you set from your own, and based on this value, you can switch or control how your view will react to this value. So to create a parameter here from this menu, create parameter. This parameter can have different types, so data types. So I will go with string. What I will do, I will create a parameter and give it two values, sales and profit. And based on the value of this parameter, I will switch the displayed measurement here, sales, to be this to display sales or profit based on the parameter value. So I can rename this as measure name and give it a sales, and here so that it can take sales or profit. Okay, so when I created here, I have this parameter created for me, and it can take one of two values, and I can add it to my view. From here, right click add to sheet. Sorry, show parameter. So here's our parameter, sales or profit. Okay, but it does not do anything. Even the color here should not be. So this one, changing between sales and profit, and it has no effect yet. So what I will do, that I will create a calculated field that reads this parameter value and assign or return the value of the profit or sales based on that measure name, and use the new calculated field in my view. So from here, go create calculated field, name it this measure. And based on the value of my parameter, so I will do if condition, if measure name equal sales, then it should return the sales value like so. Else can even do it like so, even measure name was profit, then profit, and should work with the single, no, yeah, the single. So here what I did is checking the parameter value. So if I pass the sales value to my parameter, it will return, this calculation will return the sales, else it will return the profit. Then hit apply. So now I have this measure that will switch its value based on the selected parameter here. So I will go and add it to my view. Yeah, so as you can see here, I have two measures, and as I am selecting sales, it displays the sales exactly like the sales. So I don't need this one now. So here we have the sales displayed based on on the selected parameter, measure name, sales. So if I go and change it to profit, my view updated, and now it's displaying the profit value for each product name. So if I go back to my view and add the parameter to our sheet, it will be added here, measure name, and can set to sales, profit, and so on. Okay. Also, as you can see here, my title is a static text. So even I can refer to this parameter in my title to make the title dynamic as well. So here from the title, we can replace this one from insert here and refer to the parameter measure name. So this way, my title here even will change based on the selected parameter value. And I think this one as well will be updated like so. Okay. So yeah, I am done today with the items that I prepared for you, and let's take the remaining time to listen to your questions and answer any questions arises, as today is our last session. So I would like to listen and know if you have any questions regarding today's session or any other previous session.
I was just curious about one thing when you were doing the forecasting and stuff like that. Some of those models are familiar to me, but I'm just wondering, can it be extended? Can you plug in different forecasting models?
Yeah, the different forecasting models, I'm not sure if you can use the R integration to apply any implemented algorithm from R, implemented forecasting algorithm from R to your view in Tableau. But I think this should be should be able to do so from our integration. But regarding the out of the box forecasting, this is just the exponential smoothing algorithm, and even for the parameters that you pass to this algorithm that determine how accurate is it or the confidence interval, you can just play around with these values as here forecast option.
Yeah.
So yeah, you can set it to include the seasonality or customize the trend. Is it will be additive or multiplicative modeling. Also the prediction interval. So this one is what comes out of the box with the product, but I have not I have never tried the R integration with Tableau, but I think you can utilize this integration to, if you have like a ready library or library that implements a different forecasting algorithm, you can include it and use it within Tableau. But for sure, to use R in Tableau, you should have R installed in your machine. As Tableau doesn't have the R libraries or compiler or these infrastructure things. You should have this in your machine, and then Tableau will accept the script here as a calculated field.
Right. Cool.
Script, yeah. Script. Yeah, any one of these four types, depending on the returned value of the script, whether it's Boolean or integer or real number or string, and just use it like so. Put your R script inside these brackets. Okay.
Nice. Okay. Thanks.
So, any other questions? Okay.
Just kind of curious, what happens when there's a divide by zero error in a calculated field that you make?
Yeah, I faced this situation before. I think it just displayed the hash DEV or DIV. Just like an error during the division, but let's try it. So okay. Here, division. So let's try sales by 0. The calculation is invalid. Okay, good. So we try it. Where is it? It's not showing anything. Yeah, as it detected the error itself. But sometimes if you have instead of explicit 0, you have like sales per profit or per anything, and as per your data set, this profit comes with 0 value. So it will display a hash like hash div to indicate error during the division.
So if you have a bunch of data that you do, I don't know, sales over profit, and one record happens to have a divide by 0 error, is that something you have to explicitly account for and manually fix? Or do you do...
Usually you can. It will not blow the visualization, not blow it up. It will just display error regarding this row of data, and you can simply detect this value using if condition, and also I think there is some functions to deal with nulls. Yeah, if null is null. So yeah, usually I used to use these functions if you got like an empty field for profit, so you can assign it to a different value or handle it with minus or anything that represent the situation. And also, let me show you here the case when we had 0. Yeah, 0. Yeah, see here this indicator, 1 null. So usually if you encounter this situation in a very complex dashboard like so it will simply display this hint down there or warning in down of your sheet, and by clicking on it, it will ask you if you want to filter out this data or set it at default. This one, put it like a default 0. You can filter it out, so it will be excluded from the view. Okay.
Alrighty.
Any other questions? Okay. So what I wanted to mention at last, that you know, the tool itself, it has a lot of features, and even more features than we presented. But given the limit of 4 hours that we have, I tried to go through most of them and try to provide a wide overview, so not to focus on a single area of the tool. But if you are interested in Tableau, you can go and check even the official training from Tableau. It's free and open. You have videos and sample sheets and datasets and so on. Might take you like a week of study, but it's worth it. Also, there are a lot of online resources. I will share some books and websites for you on that channel. If you are interested in the tool or even the data visualization as a concept and you want to study more about it, I can provide you with some good resources. Yeah, and thank you all for attending today and the previous weeks.
Thank you very much. This was great.
Yeah, I learned quite a bit over these 4 sessions.
Thank you.
Thank you.